Ma'am, we were like in the last, like second last step only in the rocket numerical.
Did you get this value? Did you get this
Yes,
R by X?
it's from 2.59 into 10 raised to.
Ma'am, one decimal is fine, right?
One decimal place is okay. Have you completed this? Or you need to complete? Was textbook numerical 8.12. Have you completed or? Okay. Okay, fine. 1 second. I'll put an empty slide. So the value was r minus x by x was equal to root of ms by me. That was the value.
Yes, ma'am.
Okay. So you know how to take the square root, boys, or should I do that those values? Should I teach you to take the square root? Okay. So r minus x by x was happens to be 577 because this was 2 into 10 to the power of 30 divided by what was the other one 1.6 into 10 to the power of 24. What was ME? Okay, 6 into 10 to the power of 24. Okay. So that comes to be, was that comes to be 1 by 3 into 10 to the power of 6. So I can take 10 to the power of 6 outside the square bracket, correct? By root 3. So in that case, 10 to the power of 3, I can write it as 1000 divided by 1.732 because root 3 value is 1.732. So if I want to shift, what I can do is I can again multiply by 1000. I can make the whole number. Yes or no, boys? Right? I'm just using, boys, I'm making the denominator a whole number by multiplying by 1000. And then the numerator also should be multiplied by 1000. So this comes to be, for me, it will be somewhere around 0.577 10 to the power of 3. Or I can write 577. This ratio, correct? So that ratio I am putting over here. So r minus x must be equal to 577x. Or I can write, because I want to find the value of x. So in that case, r becomes equal to 577x plus x. So r becomes equal to 578x. Or I can write x is equal to r by 578. What is the orbital radius now? 1.5?
Ma'am,
10 raised to
into
11.
10 raised to 11.
Okay, if that is the case, boys, I can make x is equal to 1500 into 10 to the power of, it comes to be 8, I think so. Because 3 or 4 I have made. Okay, I have taken 3 from 10 to the power of 11. I have taken 10 to the power of 3 and made 1.5 as 1500. Now, if you calculate this comes to be somewhere around 2.58 10 to the power of 8 meters. Just check the calculation was. No, it's somewhere around 2. Yeah, that's not a problem. Was. Completed? Okay, boys. Shall I move for the next topic, boys?
Yes, ma'am.
Boys,
Sure,
we
ma'am.
have completed, 1 second. What we have completed is your orbital speed, escape velocity we have completed. What is left
I
in
don't
that
think so.
part
We
of
did
the
escape velocity.
is what happened?
Ma'am, we didn't do escape velocity, right? Guys?
You haven't
No.
done escape velocity?
We
Okay,
didn't
okay,
do
sorry, boys.
escape velocity.
Okay, fine. I think so. Then in that case, 11C I would have done. I haven't done escape velocity for you people. Derivation
No, ma'am.
also.
Last
no,
we
ma'am,
did
we didn't.
was orbital
Oh,
velocity.
okay. Then I'll do escape velocity. So what do you mean by escape velocity? Is the minimum velocity with which you have to throw an object so that the object leaves the Earth's gravitational pull and will never come back. So the minimum velocity is 11.2 kilometers per second. In 1 second, the object should travel with a speed of 11.2 kilometers. Then the object will reach the escape velocity and will leave your Earth's gravitational influence. So that is what is your escape velocity. Now, how to derive an expression for the escape velocity? You are going to check what will be the expression for your escape velocity. And you have to prove that your escape velocity will not depend upon the mass of the body which you are going
Ma'am,
to.
could you show the definition, please?
Yeah, I'll do that. Mass of the body with which you are going to throw the object higher up. Now, how will you proceed with this? In the previous case of orbital speed, we had the key expression. That is a centripetal force. Your satellite is revolving around the Earth in an orbit. In that case, the centripetal force must be equal to the gravitational force. If you know that expression, you can derive. Now, here, what you are going to do is that you say the body was initially lying at point A, which is on the surface of the Earth. The body was initially lying at point A, which is initially on the surface of the Earth. You want this body to be moved to infinity. The body has to escape from the Earth's gravitational field. It has to move to infinity. So what work you have to do in making the body, which was initially lying at point A, the body is lying at point A, you want to make this body to move to infinity so that it will not come back to Earth's gravitational field. It's escaping Earth's gravitational field. So to make the object to move from the surface to infinity, you have to do the work. And the work done in moving the object, from the surface to infinity. Whatever work you do will change the kinetic energy of the body. Work energy theorem tells you that the work you do will change the kinetic energy of the body. Say initially the body was at rest. So when you do the work, if you want to project the body higher up, generally we use your rocket system, multi-stage, which means you're doing a work in pushing the object from the surface to infinity. Whatever work you do will increase the kinetic energy of the body. Okay? So you have to first find what is the work you need to do in pushing the object from the surface to infinity. And that will be equal to the kinetic energy of the body or the kinetic energy gained by the body. The body will gain its kinetic energy, right? And from kinetic energy, half mve squared, you can find the velocity with which it is traveling. That becomes your escape velocity. Boys, are you clear about the key concept over here? 11b.
Yes, ma'am.
Yes.
So just write first write what is escape velocity, the definition you write, and just write the key concept. Then we'll have to solve the key concept stepwise. Work done to move the body from the surface to infinity will be equal to kinetic energy gained by the body, where your VE becomes your escape velocity. From there you can
Ma'am,
find.
what should you write?
So you just write after your definition, just write, should I erase and write it properly? Okay.
No, ma'am.
Right? The key, no, I'll write the key concept. What is the key concept? The work done in moving the body from the surface to infinity. That will be equal to change in kinetic energy or energy, gain in kinetic energy of the body. So that is half mve squared. So this ve is your escape velocity. So you have to find the work done, equate it to half mve squared. From there, you have to get an expression for ve. Is that clear, boys? So that will be your key concept.
Ma'am, is this part of the derivation? Like this key concept?
Whenever you derive, you should know where you have to start. Otherwise, so many derivations, how can you retain, boys, in your mind? You should know where you have to start and in what way you need to proceed. That's what I just wrote a key concept. This key concept is only when you are learning. Don't write it during exam, right? That's for you to learn. And introductory part, you can write by yourself, right? Otherwise, I'll put this, boys, what I'll do is I'll put this PPT in your file section. Later, you copy down the introductory part. We'll start with the derivation because it takes a lot of time. Shall I erase this, boys? What happened?
Do we have to draw the diagram?
Diagram is important. Now look at this. How will we proceed for, boys? How are you going to proceed for finding the work done in moving the body from where you have to move the body? If the body has to escape Earth's gravitational field, you have to do a work in moving the body from where, boys? From the surface. Surface means from a distance, or whenever you are measuring the distance, it should be from the center of the Earth. When the body is lying on the surface, when the body is at point A, it is at a distance of r meters from the center of the Earth. So from the surface of the Earth to infinity. Is that clear, boys? From surface to infinity. Now, how are you going to do this? So what you do is that at point P, you're imagining the body which has to travel with an escape velocity. So let us consider the body initially was of mass m was at point P at a distance of x meters from the center of the Earth. This is what I have to, sorry, yes, I need to find this. I need to find this. For that, what we'll do is we'll consider a body of mass m initially at point P, which is at a distance of x meters from the center of the Earth. If I have a body at point P, right, your Earth is having a mass m. You have two different bodies separated by a distance of x meters from them. So then what is the force of attraction between them according to Newton's universal law of gravitation? Kavin is in your class. Kavin is in your class. Kavin? Your microphones are going on.
Yes, ma'am.
Kavin?
Yes, ma'am.
I'm considering a body of mass small m placed at point P, which is at a distance of x meters from the center of the Earth. Now you have two different bodies. One is of mass small m, the other one is your Earth of mass capital M. According to Newton's universal law of gravitation, what is the force between them? What is the force acting between them? Okay, fine. What is universal law of F is equal to G? I have two bodies. Which are the two bodies? One is having a mass. One is having a mass.
Yes, ma'am. Yes, ma'am. Phone was ringing. That's why. Ma'am, could you repeat the question?
So what is the equation for the force between the body of mass m and the mass earth of mass capital M, right? If I'm moving in this way, I will not be able to complete theory as well as your numerics. What is the force? Okay, 1 second.
Ma'am,
I'll ask someone.
mass.
Abhishek. Abhishek. Abhishek.
Yes, ma'am.
Austin.
Ma'am, can you not hear me? Hello?
Austin. Okay, right, boss, right? All of you. Consider a body of mass m. I think so. Your December PT3, I'll take. You're not responding, boys. I'll just keep marking. So PT3, let us put yes.
Abhishek said yes, like when you called it.
Right, boss.
Ma'am,
Consider.
he has a weak microphone. Just give him another
Okay.
chance. Abhishek,
yes, ma'am.
could you just?
Ma'am is actually speaking, but sometimes you can't hear because
Okay.
it overlaps.
Fine, boys. Right, boys. Suppose a body of mass m lies at point P from its center, right? What are you considering? You're considering a body of mass m, which is at a distance of x meters from the center of the earth. So then the gravitational force of attraction between them will be capital G, mass of the earth, mass of the body, and what is the distance between the body and the earth? It is x. Is that clear, boys? Okay. Next step, what we need to do is that let us find what is the work you have to do in moving the body from point P to point Q. Look at the force of attraction. This force is going to act towards the earth, right? So if you want to move the body from point P to point Q, right, to a very small distance, you're going to move the body from point P to point Q, traveling a distance of dx meters in a direction opposite to the direction of the force. So then you need to do a work. So you have to find what is the work done in moving the body from point P to point Q against the force of gravitation, right? Right, boys. The work done in moving the body.
Ma'am, can you show the
Yes.
statements? Just take a screenshot.
Okay.
Yes, ma'am, done.
Boys, what will be the work done in moving the body? Work done in moving the body from point P to point Q against gravity. Okay. It is a very small work you do, dW. So that must be equal to what? That must be equal to, work is what? Work is force into displacement, F into dx. Is that clear, boys? Is this clear? Is this part clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now what you have to do is that, what is your aim? What is the work you have to do when the body which was initially on the surface of the earth, you have to push the body where? You need to push the body to infinity. You have to push the body from point A to infinity. Now you will understand the concept of integral calculus now. Now the body is initially at point A. Now you need to push the body from point A to infinity. Is that clear, boys? I'm just pushing the body from point A to
Yes, ma'am.
infinity. So what we'll do is the distance from point A to point infinity, we'll divide it into a number of segments, right? each of dx, dx. I'm just explaining why integral calculus has to be brought here. Your aim is to find what is the work you have to do when the body was initially on the surface of the earth. Now where it has to move? It has to move to infinity. So you have to do a work against gravity. So the distance from the surface of the earth to infinity, hypothetically, I'm dividing it into a number of segments, right? So if the body has to move to a distance of dx, what is the work done? dw. Again, from one more time, dx, dw, again. So what will be the total work? How many times I should add? Okay, how many times? Yeah, it has to be added infinite times. Are you clear, boys? You have already calculated what is the work. You have already calculated what is the work that has to be done in moving the body to a distance of dx. That already you have calculated. Say that work is 1 joule. To move the body to a distance of dx is 1 joule. From the surface of the earth to infinity, then what do you have to do? You have to add all the dw's. Is that clear, boys? Is it possible to add? Is it possible for us to add all the dw's? It becomes difficult. That is why you introduce your integral. Is it easy for you to add all these dw's? Look where you are starting. You are starting from the surface of the earth. You are going to infinity. Is it possible for you to add it? It becomes difficult. That is where your integral calculus comes into picture. Is that clear, boys?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Have you, right, boys? The small work done in moving the body. Why I'm insisting you students to write is that surely you will get this, either this or the previous one as your 3 marks question. The small work done in moving the body to a distance PQ against gravity, dW is equal to F dx. So what is F? Gmm divided by x squared dx. So you have calculated what you have calculated, the work you do in moving the body from P to Q. Now your aim is to find what is the work done in moving the body from point A to infinity. That is your aim. So the total work done in moving the body from the surface of the earth, that is at a distance of r, to infinity. And boys, now I'll use the integral calculus. Can someone put this in the chat box, boys? Not you. Not you, others. Boys, those who are at home, can you put this in your chat? Sorry, take this, put this in the chat box so that I can go for the derivation part. They can hear. Boys, 11B, you can hear. Can you hear?
Yes, ma'am. I did it.
Now, let me do this calculation. Yes, I'll take a new slide. So, the total work done is equal to, the clear, boys. What is dWF? Here. So from where it has to move, the object has to move from the surface, which is at a distance of r from the center of the earth to infinity. Is that clear, boys? So then next step, what is F? Gmm divided by x squared dx, r and infinity. The mass of the earth is, m is a constant. The mass of the body is a constant. G is a constant. All constants should be taken outside. So now I'll get Gmm divided by r to infinity 1 by x squared dx. You understand this? Okay, next step. It becomes Gmm m, the total work, I can write x to the power of minus 2 dx 1 by x squared. Can I write it as x to the power of minus 2 dx? Fine, boys. Now I have to go for identity. Now, what is your identity? The limit is r to infinity. So what is your identity over here for integral calculus? X to the power of n dx will be equal to x to the power of n plus 1 by n plus 1. Is that clear, boys? Right? Here in this case, what is n? N is minus 2. 11b.
Yes, ma'am. So it's x raised to minus 1 by minus
Now
1.
this becomes g m m. Now if I solve this integral, it becomes n is what? Minus 2. Minus 2 plus 1 by minus 2 plus 1. Still I have the limits. Correct? Okay. So now what will I get? GMM by x to the power of minus 1 minus 1. Copy down first, then I'll have to erase the screen. Identity, put a right column and do. Is there anyone who is having a doubt, boss? 11b. Danish. 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 Maheshwar. Vishesh. I need to keep calling you boys.
Yes, ma'am. What up?
Boys, is that clear or should I redo
Yes, ma'am.
once again?
It's clear, ma'am.
It's clear, ma'am.
So just copy it down so that the left column, extreme left, I will erase and then we'll proceed.
Man, do we have to copy this down?
Yeah, you have to copy. Have you copied the identity also? So what I'll do is I'm just erasing. Shall I erase the identity?
No, ma'am. No, ma'am.
So now this is work. So minus 1, shall I take it outside? Minus GM.
Ma'am, but you erased that thing which was there.
Okay, I'll write the identity. You can. One second. One second. Identity I have. This is only the identity you copy because I have.
Ma'am, our English period started, ma'am. Can we leave?
Yeah, you can leave.
Thank you, ma'am.
Thank you, ma'am. Ma'am,
Yes.
this is Siddharth. Could you just quickly give me the list of the SFS points of physics?
Which one?